Lesson we're going to be looking at grade 12 momentum questions. So in the first example we're going to be doing is the following. A metal ball of mass 2 kilograms is dropped from a certain height above a concrete floor. It reaches the floor at a velocity of 10 meters per second and rebounces off the floor at a velocity of 4 meters per second as shown in the diagram below. Ignore the effects of air friction. So the first question, they're asking us to go and calculate the initial momentum of the ball at which it reaches the floor. So the formula for momentum is P is equal to mass times velocity, P being my momentum. The mass of the ball is 2 kilograms and the velocity at which it reaches the floor is 10 meters per second. So together, my momentum is going to be 20 kilograms per meters per second. Then the next question, they're asking us to go and calculate the final momentum at which the ball reaches the floor. So now we're going to say my P final is equal to mass times velocity. So what the information that they give us is the velocity is now moving at 4 meters per second, but it's moving upwards. So what I'm going to have to do now is I'm going to have to change this to a negative sign so that my formula shows that. So my mass still remains 2. My velocity is now negative 4, which means my final momentum is going to be 8 kilograms per meters per second minus 1 away from the floor or upwards. Remember, if we get a negative answer with these, it just means that my sign has to change. Right. Then the next question says the magnitude of the force exerted by the surface on the ball during contact is 1419.6 newtons. We have to define impulse. So impulse is the product of the resultant force acting on an object and the time the net force acts on the object. So the next question they ask us to calculate the time for the ball to be in contact with the surface. So we are going to go and have a look at all of the forces that would have played a part over here. So we're going to say that our F net is equal to our Fs, which is the contact, plus the Fg. So they give us the surface or the contact, that's already given, and we can go and get the Fg. So my F net is equal to 1,400 newtons. You will see that the force that the ground exerted on the ball, I made negative. And the reason for that is initially I decided that down was positive. That's why for the first question over here, my 10 meters per second when it was moving down towards the floor was positive. And here when it was moving upwards at 4 meters per second, I made it negative. So obviously the force of the contact force of the ground on the ball is going to be acting in an upwards direction. Therefore the sign is going to be negative. Right, once I have this, I can go and use my impulse formula where my F net times my time is equal to my change in momentum. So I have my F net now, and I'm still going to use the sign that I got. So this answer was obviously negative. I'm going to use that negative answer in my answer. And my change in momentum is where I minus these two from each other. So where I say right, so you'll see that my change in momentum was equal to my momentum final minus my momentum initial. So my momentum final was negative 4. Then my initial was 20. Or was it 8? Sorry, it was 8. My apologies. My final momentum was 8. and my initial was 20. So because of the signs that I had to take into account, it was negative 28 kilograms per meters per second minus 1. All right, so the total amount of time taken was 0.02 seconds. All right, in the next question, we have a wooden block. A wooden block of mass 2 kilograms moving at a velocity of 5 meters per second. So anytime I have a question like this where we have blocks before, where we have blocks before collision and then blocks after collision, we know we're going to be working with sigma. And sigma just means the sum of. So you can only do this if the system is enclosed. So an isolated system is when I can use the sigma. All right, but we'll have a look at that in a second. So the first question is, state the law of conservation of linear momentum in words. So the total linear momentum of an isolated system remains constant. All right, so it's always conserved in an isolated system. So whatever the momentum was before will be equal to the momentum afterwards. And that's obviously very handy when we have to go and calculate either the velocity or the mass before or after the collision. Right. Then this 2.2 asks us to explain what is meant by an isolated system. It is a system on which the net external force is 0. All right. So in the next question, 2.3, they're asking us to calculate the velocity of the wooden block immediately after the collision. So I'm always going to go write my sigma sign. So my initial momentum, the sum of my initial momentum must be equal to the sum of my final momentum. So because there are two blocks, I have to go take the formula for momentum, which is mass times velocity. So I'm going to take it for the first block, and I'm going to add it to the second block. This is obviously this is before. Then I'm going to go do the same thing after. So I'm going to say the same formula, I'm just going to repeat. So if I go fill in everything that I have the first block's mass, it's 2 kilograms. I also have his velocity, which is 5. Then the second block I know weighs 9 kilograms, but they tell me that it is resting. So I know the final velocity or the initial velocity for the 9 kilogram block is 0. Then after collision, they told me that my final velocity of the first block, of the 2 kilogram block, is unknown. So I still have the mass, but the velocity of the first block is unknown. We do know that the second block, the 9 kilogram block, moves away at 1 meter per second. All right, so taking all of this into consideration, I can go and solve this to get my velocity to be equal to 0.5 meters per second minus 1 to the right. Right, now the second question, they're asking us to prove if it's elastic or inelastic. So to prove elasticity, if something is elastic, it means that the kinetic energy before is equal to the kinetic energy after. So remember, the formula for kinetic energy is half mv squared. So you're going to take the total kinetic energy before and see if it is the same as the total kinetic energy after collision. So let's go start by calculating the kinetic energy before the collision. Okay, so I'm going to go put in the mass. We had the velocity as 5. Then on the second one, we had the mass as 9. We had the velocity as 0. So this was 25 joules. Remember, we measure energy in joules. Then my kinetic energy afterwards, I calculated the final velocity of the second block as a half. And this one, for the 9 kilogram block, they gave it to us 1. So therefore, the final is 4,75 joules. So therefore, my kinetic energy before is not equal to my kinetic energy final, therefore it is not elastic. Right, let's go have a look at one more question. So here we've got two objects, object P and object Q, and their masses are 10 kilograms and 5,000 grams respectively, and they collide head-on as shown in the diagram. So as soon as we see head-on, we know that a factor that's going to be super important is direction. So we're going to have to be very clear. Oh my goodness. We're going to have to be very clear about, direction. Alright, so after the collision, the 10 kilogram object has a velocity of 14 kilometers per hour. That's something else I need to take into consideration. We're working here with kilometers per hour, which is problematic. And then they say we must ignore the effects of friction. So the first question is to explain what is meant by an isolated system in physics. So this again, we already spoke about this, but it is a system on which the net external force is 0. Then they say we must calculate the velocity of the 5,000 gram object immediately after collision. All right, so we are once again going to go write our sigma. So we're going to say our change in momentum, or the sum of our momentum before, will be equal to the sum of the momentum afterwards. Then I'm going to go write down my formula. You know in science how important it is to always go write down your formula. Another thing that they're also quite pedantic about is when you fill things in. So if you, for example, have mass and then velocity, when you actually sub the numbers in, please make sure that you put the mass under the mass and not switch them around, because sometimes they can be quite pedantic and they can take marks off for that. So just always be aware of working like a perfectionist in science. All right, so let's go fill in what we have. For the first block, we have the mass as obviously 5,000 grams is 5 kilograms. And we have the velocity as 2. All right, so I'm going to say that right is positive. So anytime my answer is positive, it was in the right direction or in the direction towards the right. And if it's negative, it means it was in the opposite direction, so towards the left. All right, then my second one, the mass we have for this one was 10. And then we have the velocity as 12 meters per second, but I'm going to make it negative. Then for the second block, so once again, I know that the mass is 5, but my velocity is unknown. My mass for the second one is still 10, but now they're telling me that it's moving 4 meters per second to the left. All right, so how we would have known that is we would have said 14,4 times by 1,000 divided by 60 times 60. So that's how you're going to change kilometers per hour into meters per second. So my final velocity when I go and solve for this, for the first block, is 14 meters per second minus 1. The answer was negative, which means it is just 14 meters per second minus 1 to the left. Right. Then the next question is the collision between the two objects elastic or inelastic? So remember we said elastic or inelastic means that the total kinetic energy is conserved. So if the kinetic energy before is equal to the kinetic energy afterwards, then it is elastic. So let's quickly go find out the kinetic energy before. And then the kinetic energy afterwards. And this one, the total kinetic energy was 570 joules, therefore it is not elastic. Because my EK before is not equal to my EK after. Right, then the next question says, the collision between the two objects lasted for 0.01 second. As soon as time comes in, I know impulse is going to be playing a role. So they say we have to distinguish between an elastic and an inelastic collision. So an elastic collision, like we just established, is a collision where the total kinetic energy is conserved, and an inelastic collision is where the total kinetic energy is not conserved, right? So now they're asking us to calculate the force exerted by object P on object Q. So that's where we're going to be using this formula. So F net times delta time is equal to my change in momentum. All right, we don't know the F net, that's what we're trying to calculate. They give us the time as 0.01, right? My change in momentum. So they're asking me specifically of object P on object Q. So what we're going to be working with is specifically the information from Q, right? They want to know what was the force that happened on Q. So what we're going to do is we're going to take the mass. So the change in momentum is obviously mass V final minus V initial. So we're going to use this for the block that weighed 5 kilograms. So we're going to say 5, then we had negative 14 minus 2, because remember we have to take our signs into consideration. So then my F net was equal to 8,000 Newton to the left.